Japan just photographed something that looks almost impossible, a two-headed asteroid. It was 62 million miles from Earth, yet the image came back sharp enough to stop scientists cold. The asteroid is called Torifune, and this was not a planned original mission. Hayabusa 2 was supposed to be done after bringing asteroid samples home. But the spacecraft kept going, and on July 5th, it flew into one of the riskiest bonus shots in asteroid history. The target was small, fast, and poorly known. From Earth, Torifune had mostly been a moving dot. Up close, it looked like two worlds fused together. That shape is not just weird, it is a clue. It can reveal how rubble piles form, collide, and survive for millions of years. And it gives planetary defense teams a live test with almost no margin for error. This is the story of the two-headed asteroid, the old Japanese probe, and the image nobody had seen before. The flyby happened on July 5th, 2026, at about 6:35 in the evening Japan time. Ground controllers confirmed that Hayabusa 2 was still operating normally right after the pass. The most dramatic image came from the optical navigation camera. Another instrument saw the asteroid in thermal infrared. The two images together told scientists where Torifune was lit, where it was cold, and where its roughness changed. At closest imaging, JAXA reported the spacecraft was roughly 10 kilometers from the asteroid. That is close enough that one navigation mistake could ruin the observation. Hayabusa 2 was moving at more than 5 kilometers per second relative to the target. The useful observation window was brutally short. This spacecraft was built for slow operations around Ryugu, not a high-speed flyby like this. So the Torifune pass was both science and a stress test. The result was a picture that turned a dot into a world. The first thing everyone notices is the two-headed shape. Scientists call objects like this contact binaries when two bodies touch or merge, but the exact story is still unknown. Torifune may be a rubble pile held together by weak gravity and friction. Its neck may be the fragile place where the two lobes joined, or the shape may come from spin, impacts, and material sliding over time. The asteroid is about 450 meters across. That is large enough to matter scientifically, but still tiny compared with planets. Its surface is covered with boulders of many sizes. Those boulders record collisions, shaking, and slow movement in microgravity. A two-lobed asteroid can preserve the memory of a gentle crash. That makes Torifune a frozen crime scene from the early solar system. 62 million miles sounds impossibly far, and it is. That is roughly 100 million kilometers from Earth. But for a spacecraft already traveling through the inner solar system, distance is only part of the problem. The harder challenge is timing. Hayabusa 2 had to arrive at the right place at the right second. Torifune was not waiting. The asteroid orbits the Sun in about 383 days. It belongs to the Apollo group, meaning its orbit crosses Earth's orbital neighborhood. That does not mean it is about to hit Earth. It means scientists care about understanding objects that travel through this region. Every measured orbit improves the larger picture. Torifune became one more moving piece in Earth's neighborhood map. Hayabusa 2 launched in December 2014. Its original target was Ryugu, a dark asteroid shaped like a spinning top. The mission did something extraordinary there. It touched the surface, collected material, and sealed pieces of an asteroid inside a capsule. In 2020, that capsule returned to Earth and landed in Australia. For most missions, that would be the ending. But Hayabusa 2 still had fuel and working instruments. So JAXA gave it an extended mission. Torifune became the first asteroid exploration target of that extended mission. This means the new image came from a spacecraft already past its headline achievement. It was not a brand new probe built for Torifune. It was a veteran spacecraft taking one more shot. The optical camera gave scientists shape and surface detail. The thermal infrared imager showed temperature patterns. Warm regions faced the sun. Cooler regions matched the shadows seen in the optical image. That comparison helps reveal roughness, dust, rock size, and how the surface stores heat. A smooth, dusty surface warms and cools differently than a rocky surface. Thermal inertia sounds technical, but it is really about how stubbornly a surface holds heat. For an asteroid, that can hint at what it is made of. It also matters for future deflection planning. A solid rock and a loose rubble pile do not respond the same way. So one strange photo can connect geology to planetary defense. The prettier the image looks, the more data it may be hiding. The risky part was not that Torifune threatened Earth. The risk was the spacecraft operation itself. Hayabusa 2 had to point its cameras while the target rushed past. There was no long, gentle orbit around Torifune. There was no second chance to slowly map every crater. The team had to predict the encounter geometry in advance. They had to protect the spacecraft while pushing its instruments hard. Old spacecraft can surprise you, but they also demand caution. A small pointing error could turn the asteroid into a blur. A timing error could mean the best image happens just outside the camera's view. That is why the successful image mattered immediately. It proved the spacecraft could still perform under extreme timing pressure. Why does a two-headed asteroid matter? Because small bodies are leftovers from the construction zone of the solar system. They preserve materials that planets swallowed or erased. Torifune appears to be a rocky S-type asteroid. That connects it to common meteorite materials found on Earth. Its rotation is about 5 hours. Spin affects where loose material slides and where stress builds. If the spin changes over time, the shape can evolve. Sunlight itself can slowly alter an asteroid's rotation. Impacts can shake it like a pile of gravel. A close flyby gives scientists rare ground truth for all those models. Torifune is not just a strange rock, it is a test of how small worlds survive. Planetary defense begins with knowing what is out there. Most near-Earth asteroids are not immediate threats, but the dangerous ones will not announce themselves dramatically. They have to be found, tracked, and measured. A flyby like Torifune trains rapid reconnaissance. If humanity ever needs to inspect a risky asteroid, speed will matter. We may not have years to slowly plan a perfect mission. A spacecraft may need to gather useful data in one pass. Shape matters for deflection. Mass distribution matters too. Surface texture matters because it changes how an impact transfers momentum. Torifune gave scientists a real target for practicing those questions. The phrase two-headed asteroid sounds like science fiction, but the real story is better than fiction. This was not a monster racing toward Earth. It was a rare close look at a small world we barely understood. The headline grabs attention because the shape is strange. The science lasts because the shape has a history. A two-lobed asteroid may have formed gently, not violently. That makes it even more surprising. Sometimes the solar system does not need explosions to build weird things. It only needs time, gravity, spin, and countless small collisions. So the best question is not whether Torifune is scary. The best question is what this shape is trying to tell us. Hayabusa 2 is not finished. Its extended mission points toward another target in 2031. That future asteroid is called 1998 KY26. It is much smaller than Torifune. Studying it could push asteroid exploration into an even stranger scale. But Torifune is now the proof that the spacecraft still has sharp eyes. It crossed deep space, survived its main mission, returned samples, and kept working. Few machines get a second scientific life this dramatic, and few asteroids make such a strong first impression. The first images are only the beginning. More analysis will turn the dramatic picture into measurements, maps, and papers. For now, one thing is clear. Japan just gave the world a close-up of a genuinely alien shape. A dot became an asteroid. An old spacecraft became a deep space scout again. A risky pass became a new scientific reference point. And a two-headed rock became a reminder that the solar system is still full of surprises. The strange part is easy to see. The important part is what scientists can measure from it. Shape tells a story. Temperature tells a story. Motion tells a story. And every story helps us understand the next object before it arrives. Torifune was far away, but the lesson is close to home. Keep watching the small worlds. They are the ones that teach us how planets stay safe